Okay, folks, in this module in chapter 13, we're going to be talking about the developing mind. So we're going to look at some historical developmental psychologists and some pioneers in the area, specifically focusing on Binet, Piaget, and the study of intelligence. So as we go through the developing mind, we'll talk about Binet's early life and career. If that name sounds familiar, it's because he's often associated correctly with the Stanford Binet intelligence test. And so we'll look a little bit at the history of that work and the rise of intelligence testing. And Piaget's early life and career. So this was one of the first cognitive developmental theories that was put forward, even though it was a bit of armchair psychology again, because he was really focusing on looking at the stages his own kids went through. It was still ended up being impactful in the field. We'll also talk a little bit about genetic epistemology and the stages of development and finish up with other places that Piaget influenced the field and some researchers who kind of piggybacked off of his work. So Binet's early life and career, he was French, he was a psychologist. He ended up promoting a faulty theory of hypnosis while working for Charcot and then went on to conduct experimental studies on the suggestibility in children before switching over to intelligence testing. And so that's what he was really much more well known for and what we recognize him for today. Had he stopped his career at this point, we probably wouldn't know anything about Binet or talk about him. Individual psychology was what Binet talked about or named when he wanted to develop a short series of short tests that would produce information about a person that was comparable in richness, complexity, and comprehensiveness to that obtained through an in-depth case study. And so a lot of different places within psychology we see this term individual psychology, but here it's really being used to describe a person at their individual level, because again, in so many other areas we talk about people as they differ from the norm, but talk about the norm as that being what everyone should be. In this area, Binet really focused on defining the person. So as he started to work up a battery of testing, and Binet actually worked at first on his own children as well, some of the tests that he was attempting to get them to take and kind of look through were projective tests. So tests where the individuals were shown ambiguous stimuli, such as ink blots. We think of the Rorschach test when we think of that, pictures or objects, and asked to report what they see in or think about the stimuli. And so these were kind of early forerunners of those more well-known tests. We've talked about the thematic apperception test. That's another projective test. But basically, projective tests are anything that a client can look at and give their own opinion or own interpretation on. However, as he started to go through further and revise some of these ideas, one of the terms that came up was intellectual level, and that was the term for the single score that children received on Binet and Simon's intelligence test. So an intellectual level, not an IQ score at this point. And we'll get to the point in testing where we name it that. What we refer to as mental orthopedics was a program of mental exercises developed by Binet to increase intellectual levels in children. And this is actually kind of an interesting thing to discuss as well. So sometimes when we talk about intellectual levels and the things that people would and are willing to do to increase their either memory or their cognitive abilities, there are a lot of faulty training programs out there even today. And so you might have heard of luminosity or things like that for training your mental abilities to improve on these tasks. And there's a positive and a negative side to these tasks. So they sometimes do improve performance on a specific task through training, but that's not necessarily due to what you're exercising within the brain. That's more due to task repetition and things of that nature. And a lot of times we don't see those effects transfer into more general cognitive abilities. And so at this point in time, that wasn't something that was well known, and you can respect the idea of trying to improve performance on these types of tests, but the performance improvements might not be for the reasons that they initially thought. So this idea of intelligence testing caught on pretty quickly. Researchers and other individuals in industry started to think that this might be a useful ability. So the ability to kind of separate people who were applying for jobs, who might potentially be in the Army, out based on what would become known as an intelligence quotient later. But At this point in time, Charles Spearman was an English psychologist, and he proposed that there was a notion of general intelligence and also the two-factor theory of intelligence. He referred to general intelligence as a single factor and generalized mental power, which is applicable in some degree to all intellectual tasks. And so he contrasted this with a second type or a specific factor of intelligence which is unique to the task. And so that was his two-factor theory of intelligence. So the performance of all intellectual tasks requires that single common factor and also a specific factor. And so people can have that specific factor in varying quantities, and they can also have general intelligence in various quantities. And so some people might be at the same general intelligence level, but their performance with that specific factor on a particular task may differ. And that was what he thought would differentiate them in the long run, was those differentiations within those two factors. And this isn't the only, by the way, intelligence theories that are available. We now have multiple theories of intelligence and theories of multiple intelligences. And so not just looking at generalized intelligence or even this two-factor theory, but really we have many more available nowadays. So the things that we commonly use today to go ahead and calculate an IQ quotient for an individual who takes one of these intelligence tests, and we're going to talk about some developments that aim them beyond just children in just a moment here, are the chronological age and the mental age of the individual taking the test. And so mental age was the term that William Stern used in place of Binet's term intellectual levels, and that really gets us to IQ. And that's the age at which a child tested on an intelligence test. So to give you an example of this, let's say that the child is taking an IQ test when they are in 8th grade and they are 14 years old, but the results of their test like they are an 18-year-old. And so we would have mental age over chronological age. We would multiply that by 100 and we would get the child's IQ score. And so that IQ score, as we're going to talk about, is a standardized score, and that's really where we're moving forward. So moving from intellectual level to a standardized score that can now be compared across the population, which is what we do with IQ scores. So intelligence quotient is that formula developed by Stern to summarize the results of a Binet type intelligence test, consisting of the ratio of mental age to chronological age. And if you don't multiply it by 100, you simply end up with a decimal point or a 1 point something. And so that's why most researchers will go ahead and multiply that by 100 and get a standardized score that is distributed evenly around what should be normal intelligence, which is mental age over physical age, times 100. And so it just ends up being 100, because if you are 14 and you perform like you are 14, that's 1, because it's 14 over 14. You multiply it by 100, it's 100. And so IQ scores are one of the things that researchers think are normally distributed. And again, that the mean for the population is 100. And the further away people get here on this side, the more gifted they are. And we'll define that in just a second. And down on this side, you get to a certain point and you are intellectually deficient. And so we refer to this when we're talking about individuals who are suffering a lot of times from different types of birth defects or mental health issues, disorders, not issues, but things like that. And so there's typically very specific things that are causing those intellectual deficiencies on the other end of the spectrum. So looking into these ideas, these opposite ends of the spectrum in a little bit more detail, Goddard was an American psychologist who translated Binet's intelligence tests, because remember they were originally in French, into English, and advocated for their use. And feeble-mindedness at one point in time was a common term for intellectual subnormality or intellectual disability. We no longer refer to feeble-mindedness. Another one that came and went was the word retarded. That's also in the history of description of that intelligence quotient curve. And so again, the correct term that we're using is either intellectual subnormality or intellectual deficiency in one way or another, depending on the cause of the issue. Terman researched giftedness specifically and worked on testing, intelligence testing with the Army during World War I. And he introduced what's referred to as the Stanford revision of the Binet intelligence test. So you heard me refer to earlier in the lecture the Stanford Binet intelligence test because that's the one that's commonly used today. It's the most widely used intelligence test in North America. Obviously, it has been revised a few more times since this point in time, but that is at the core of it. There is not just one intelligence test. There are actually multiple types of intelligence tests. The ACT and the SAT are not intelligence tests. They are instead adaptiveness tests. So they're college readiness preparation tests, but they're not IQ tests in a traditional sense. IQ gets at different components of generalized intelligence and not just kind of application of that specific knowledge. But anyway, so this is the most widely used intelligence test in North America. During this time period, they were trying to use it within the Army to sort people into different groups. So were you cut out to be in tactical? Were you cut out to be in maybe something where you had less responsibility? So that's one of the reasons that it was being used. There's a lot of controversy and distrust between psychologists and the Army, and that's been throughout history because of some of the applications and usages of psychological research. And so this was kind of interesting that during World War I, there was this clear application and working together of this idea. IQ, we finally ended it. So this is Terman's revision of Stern's intelligence quotient. This is when we get to the point where we are multiplying by 100, and an average level of intelligence is then 100. Terman also defined that upper end of the spectrum as giftedness, and he argued that it was the intelligence level of children whose IQs were much higher than 100. We now know, and we talk about the standard deviation of intelligence being 15. And so what I mean by that is if we go ahead and draw that normal curve again, and we have that mean of 100 in the middle, that when we are one standard deviation above that, we are at 115. When we are two standard deviations, we are at 130. And within this two standard deviations above and two standard deviations below our IQ score, that's our normal Q score, we've got approximately 95% of the population accounted for. And so it's kind of important to know when we're talking about giftedness, we're kind of talking about this area over here. We're not talking about something that's close to that mean. We're instead talking about something that exceeds it. Catherine Cox was a collaborator of Terman and a student of his who looked at the biographies of 300 different eminent historical geniuses and kind of determined that had they taken their intelligence test when they were kids, that they probably would have scored high on the IQ test. And at this point in time, we didn't really have anything that was being directly applied to adults, and we're going to get to that point. But this was kind of a very descriptive historical examination, and so it was a little bit less scientific than it could be. Hindsight is 2020. It's always easy to say, oh yes, Steve Jobs was a genius, or oh yes, this person, clearly had characteristics, Einstein, of genius abilities, but we have the ability to look back and look at different decisions and things that they did and say, oh, they did that because they were a genius, not, oh, they just did that. And so this is a little suspect, at least in my opinion. So looking at some other research that was the result of this generalized IQ, Weschler was an American immigrant psychologist who developed an intelligence test for adults that's referred to as the Weschler Adult Intelligence Scale, or more commonly as WAIS, and there is an adolescent or a younger version of WAIS now too. It has verbal and performance items that were inspired by the development of distinct intelligence tests for literate and illiterate Army recruits during World War I. When we think about reading, reading is an advanced cognitive ability. It's an advanced cognitive skill. Not everybody in the world, not even everybody in the United States, is a fluent reader. And so having the ability to test for intelligence in multiple ways was actually quite a helpful leap forward. The Weschler Adult Intelligence Scale was again developed by Weschler, and it was developed in 1939 and revised in 1955 with a broader standardization sample. And this is important because the standardization sample is really what we go ahead and compare everybody against. And so if there is a person who, for whatever reason, deviates from that norm, we really want to be sure of what that norm is. And that's what that second revision allowed us to do. And this is the preeminent adult intelligence test to this day. And again, we're up in revisions of the WAIS. We don't just have two, we have multiple revisions, but the WAIS is pretty commonly used. Deviation IQs are the calculation of intelligence quotients, so they're indications of where subjects stand on the normal distribution of previous results from people their own age. And so anyone whose scores for the exact average for their age group is assigned an IQ of 100, and as you deviate up and down, then you get to those 115s or those 90s, depending on if you are above or below the norm for your group. James Flynn was a New Zealand psychologist who revealed what's now referred to as the Flynn effect. And the Flynn effect is that over the past century, as new revisions of intelligence tests have become available, subjects have been getting smarter, as measured by performance on intelligence test items at an impressively steady rate. And so a lot of times when people talk about the Flynn effect, they talk about the context of, oh, intelligence must be improving. But the other way to look at this is if we continue to give these tests and sort of prepare for these tests, and we know what form that they're going to be in, we have an advantage over the people who have taken them previously. We know more about them. We are a much more standardized test type of society than we were 30 or 40 years ago. And so those test-taking abilities become a strategy. And so critics of this have put forward, critics of the original "we're getting smarter" interpretation have put forward that we're not actually getting smarter in those underlying cognitive components. Instead, we're getting better at taking tests. And so again, with some of these different effects we talk about in psychology, there is multiple ways to interpret these. So we have finally moved forward to the other name that is probably familiar to you guys, who is Piaget. Piaget was a Swiss developmental psychologist who created genetic epistemology, and we'll define that in just a minute, which is a stage theory of intellectual development that emphasizes the qualitative differences in reasoning that characterize each stage. And so genetic epistemology in general was his term for his project to study the development of children's ways of knowing about the world. And so as we go through Piaget's stages, you'll see that Piaget argues that they investigate in different ways and they understand different concepts at different points in time. He chose this term to emphasize a possible link between biological and intellectual development, so that really as the brain ages and as the child ages, these concepts become understood and solidified, and he wanted a term that reflected that idea. So the stage theory of cognitive development argued that there were 4 sequential stages between infancy and late adolescence, and each one involved the acquisition of new strategies and new ways of thinking about the solution to problems that were previously not available with that particular child's knowledge and cognitive ability. And so the first stage, he argued, was the sensory motor stage, and that was from birth to 2 years of age. The child's intelligence only involves sensory and motor activities and has nothing to do with abstract thought in the adult sense. And so when we talk about abstract thought, if I mention to you to picture that tomorrow you have to take your car and go to the store, but maybe hypothetically the air in your tires will be low and you'll first have to go to the tire store and get that taken care of. You can follow through and you can picture carrying all those things out even though you are not carrying them out. But obviously a baby from birth to 2 years old does not have that ability. They're focused on being able to pick things up, and they shove everything in their mouth in order to be able to explore things. What does this taste like? They pick things up. What does this feel like? They explore with the information and the cognitive abilities that are available to them at that point in time, which they're limited. And so we have that sensory motor stage. And so what Piaget thought of as some of the markers between stages, one of them was object constancy. And this was a concept that indicated that a child recognized that objects continue to exist even when they're not within immediate sensory awareness. So I want you guys to think about playing peekaboo with a very young child. So if you play peekaboo with a baby, typically from birth to 2 years of age, Peekaboo works really well because when you cover your face with your hands for these kids, it's like you're going away. They can't see you, they can't interact with you, and so they are specifically thinking, okay, this person is really gone. But the object constancy marker is when kids go, oh, wait, they have not gone away. They're still there. They just put their hands in front of their face. And so pre-operational stage is when children have developed an appreciation of object constancy, but are still unable to understand that certain properties of objects remain the same regardless of their appearance. And so they understand that if you put your hands in front of your face is still there. But if you take two glasses of water and you have a glass that is kind of test tube shaped, and you have a glass that's a little bit more like a kind of a cell sheet that you might see in biology and have cells inside it. If I go ahead and pour water into my glass over here, my test tube, and the water goes really, really high, and I ask a child in the pre-operational stage, okay, I have water in this tube over here and it's really, really high. And they go, yes, I agree with you. And that child sees the water poured over here. And because this is a shallower dish, the water is lower. And you ask that child, now, does this one have more or less water than what I just poured this from? They will say less because the water is not as high. When they get to the point where they recognize that this amount of water poured into this object means that the amount of water in here is the same as was in this object, then we've passed this stage. But until that point, until they recognize that properties of the objects remain the same regardless of their appearance, so regardless if I have it in a tall glass or a small, shallower glass, they're in the pre-operational stage. And so conservation of quantity, like I just described to you, was a Piagetian term referring to the ability to perceive that overall amounts of substances remain the same, even as they assume different shapes and configurations. So same thing if I had a roll of quarters and I stacked all of those quarters together for the kids and I said, there's a lot, they're really tall here, and they said yes. And then I broke that stack into multiple smaller stacks. I haven't changed the amount of quarters that I have, but these kids might be willing to say that there are fewer quarters because the stacks that I've created now are not as high as my original stack was. And so again, that conservation of quantity is not well understood. Concrete operations stage is the third stage of development, and they gain an appreciation of abstract concepts such as quantity and volume, so they can solve both of those problems, which are conserved even as the substances undergo changes or appearance. So just like when they moved from our first stage to our second stage and we had from sensory motor to pre-operational, they understood that peekaboo, your face was still there. Now if they've got that conservation, they've now moved from pre-operational to concrete operations. And so they understand that the water is the same regardless of the type of cup, and the quarters aren't changing based on kind of how I'm laying them out. Formal operation stage is Piaget's fourth stage of development, and it typically begins around the age of 11 or 12. Not specific because, again, it's dependent on cognitive abilities here. And it's characterized by the emergence of experimental or inductive reasoning and the ability to analyze problems systematically. And so within the formal operational stage, kids can use abstract concepts. So a child would be able to follow along with, let's say you go to the store and I give you a list of items and you've got some of the items, but you don't have all of the items, and you come home. Now, what do you have to do if you forgot some of those items? A kid would now be able to say, I need to go back to the store and get more items. So they can solve problems without being the focus of that problem or not actually having to carry it out. So based on Piaget's theory of cognitive development, there were a lot of people who were starting to work on this idea of development in children and just cognitive development in general. Vygotsky is another one who is quite often cited. He does some language work as well. So he was a Soviet-Russian psychologist and a nominal leader of an influential group of Soviet psychologists known as the Vygotsky Circle. And they promoted a sociocultural approach to developmental psychology. And so some of the things you hear about when we discuss Vygotsky are concepts like scaffolding, teaching kids to explore new ideas by offering them some help and some explanation, but not providing them with the answers. Vygotsky would say you offer different levels of scaffolding depending on where you are in that problem-solving development. Zone of proximal development is what Vygotsky used to describe the difference between what a person is intellectually capable of on their own and what's possible with that scaffolding or that guidance of someone who is more capable. And so, for example, a first grader who is learning about math for the first time, no matter what, that child's zone of proximal development is probably not going to include calculus, even if you have a very skilled teacher. Instead, it will include maybe some concepts that are later on within that particular mathematics chapter, but you will have to be limited in what you can offer. And so zone of proximal development really looks at child's ability and child's ability plus what they are capable of with good instruction. Okay, so moving to our last kind of theorist who applied some of Piaget's ideas, Jerome Bruner's term for 3 different ways of conceptualizing or mentally representing material that was being taught, and these end up paralleling Piaget's stages of cognitive development, and I'll give you an example of that at the end here, are characterized as enactive, iconic, and symbolic. So we're going to go ahead and talk about each of those terms in turn and then kind of put this together and compare it to Piaget. The enactive mode was the first mode, and a student begins by doing something with the material under study, representing it and getting to know it. Iconic mode, things are known primarily in terms of their perceptual qualities. And I want to talk about these two for just a second here. So think about what you do when you are studying. You start reading through the information, maybe you listen to the lecture a little bit. So if you're reading through it, you are doing something with it, especially if you are answering the discussion questions in the text and you're thinking about those ideas when it asks you in some textbooks for those quick concept checks. In iconic mode, maybe you are knowing the definition of the word and focusing on the definition of those vocabulary terms, even if you're not doing a project quite yet that integrates that application of that knowledge. But those two modes are then followed by symbolic mode, so the third and final mode in which the student appreciates the abstract qualities of the object of study. And so now you can take that definition, you can apply it to a situation, you can say, oh, that's an example of X, and you're able to interact with that information on a deeper level. And if you think about Piaget's stages of development, at first kids were able to just appreciate the sensory information, and they would go ahead and, as I mentioned, they shove things in their mouth, they explore, they go around, they toddle, they try and bite things to kind of get an idea of what's going on. Then they move on and they start understanding some other concepts about that. So they might understand what water is, that they drink water, they drink juice, but they don't yet understand that when it gets poured into different glasses, it's still the same amount of water. Then they move forward and they understand these more abstract qualities. And so we can see how these different areas match up with some of Piaget's work as well. And it's kind of interesting to look at. So this whole idea of development and especially intelligence testing that we've been discussing in this module really also corresponds with things like, do we think that intelligence is nature or nurture demonstrated? And so some of the earlier pioneers that we've been talking about that have looked at the influence of genetics and things of that nature, their work influenced these individuals, and we know a lot more about intelligence than we did when Spearman and Binet first started out. And we know that it is important to be in an environment where you are stimulated, that your intelligence will develop better and at a faster rate if we do so. And we also know that things like your socioeconomic status, diet are important within this. And they look at the big picture of if your diet is better, your socioeconomic status is probably better because it allows you to buy better foods. That means you're probably in a better school system that provides you with more opportunities. And so all of these are linked. However, when we're looking at that development of children and those cognitive theories of development, those are somewhat helpful to us as we look through ensuring that children are developing normally. So even though I mentioned that Piaget did a lot of work on his kids and even Binet did some work on his kids, the ideas that came from these have held up to an extent and been tested over time with other populations. And so it's interesting to see the effects that these pioneers continue to have as we look at the history of psychology.